Hi, Don. This is Phil Reuter, David Reuter's father, and we love your screencasts, and that's a tool I use to communicate with my students here at Pacific as well. So I have a screencast to clarify, hopefully more clearly than my email did, what our question is, my question is about homework, Unit 2, Homework 4, number 3 in your Algebra 1 class. Anyway, as you know, this is the problem, and I'm not going to read it to you too carefully, but your way of solving it was certainly more elegant than David's was, or mine was. I helped David with that one. Anyway, you pointed out that the best way to do it, and you're clearly right, is to just use the one point that we have for that relationship, which is the year 1999, and the height 8,850 meters. Use that combined with the rate of change, which was 5 centimeters a year, which we'll call this delta y over delta x. If it's 5 centimeters a year, that means it's 0.05 meters per year. Then that work is just wrote, I know you know how to do this, but just to make sure I'm not making some mistake. You know how sometimes you just stare at something and you're looking right at some big mistake, but you can't see it. I do that sometimes. My wife will tell you when I go in looking for something and come back to her telling her I couldn't find it. She goes right to it. Anyway, 800. Just plugging numbers into the expression that we know must hold for this point and every other. 8,850 has to equal 0.05 times 1999 plus our y-intercept, b, the height in year 0. And then when you solve that, you get b is equal to 8,850 minus, I'll just consolidate, 0.05 times 1999 is 99.95, which is equal to 8,750.05. And then, of course, the relationship we're asked to get is h, height as a function of x, which is the year, is equal to our slope, 0.05 times x plus 8,750.05. Okay, done. I assume that's what's in your answer key. I didn't. Well, we didn't see an answer key, but if we had seen one, that's what would have been there. All right. So David's work. David did this problem, and he converted things to centimeters, which maybe was an extra step, but he showed his work getting to centimeters, and then I had him just think back if it were 1999 years earlier, and how much shorter would the mountain be, and he came up with that, and just by that logic, and then he subtracted that from the original height and got this answer. And then he wrote this equation, which is in centimeters, but he even wrote, and I know his handwriting is awful, but he even explained the height of Mount Everest in centimeters, where x is the year. So I don't see how, maybe he loses some points for not doing it the right way, but I don't see how his answer is wrong. Anyway, that's our question. The question is, how is it wrong? And if this isn't the right answer, what is the right answer?